So there are a lot of deep network frameworks available. There is also CNTK. But in our case, our applications, which we are trying to automate, are executing only in Windows. So from the beginning, we were looking to see how CNTK behaves. CNTK is the cognitive toolkit designed by Microsoft. After a series of investigation, we decided to use only CNTK and TensorFlow. Why? Mainly because CNTK and TensorFlow offer this capability of prototyping in the Windows and also executing it in Windows. So you can do all these two phases in Windows, which is an important issue. Now, TensorFlow is probably the most popular deep learning framework in our days. Is very well documented. It has a lot of examples, and it also the tensor board, which allows you to view specific graphs. Allows you to view the computational graph also. So it gives you a view of your model. Another important aspect about TensorFlow, it's offered this capability of shrinking your model using the quantization modules. Also, it can be integrated, as I mentioned before, in your Windows application. TensorFlow was not designed from the beginning to support Windows. They initially supported only Linux, but after that there is support also for Windows. They work right now to a Java API. There is also a C++ API available for Windows. For those who want to integrate TensorFlow in a .NET application, there is an open source project called TensorFlow Sharp, which deals with that. Now, another framework. I'm not sure how many of you have heard about CNTK. I think it's probably the most promising deep learning tool. It was designed by Microsoft. Last week, it was the second release. Of course, it has very smooth integration in .NET using a NuGet package. Related to this object detection part. So CNTK comes with a tutorial for doing the detection. It has the fast RCNN architecture already implemented. You can use this tutorial for doing different kind of detections. What is important about the detection part on CNTK? If you want to implement, for example, any fast or faster approach, you'll have to implement this specific layer called region of interest pooling layer. And this layer is already implemented in CNTK. In terms of performances, it's a bit faster than TensorFlow. Starting from the loading part and also continuing the training part and also with the execution part. The problem with CNTK is that the lack of documentation. So there are 3 different APIs available. There is an old API. There is also some kind of script which is similar with the script from Café. It's called Brain Script. And they right now have also a new API. So it's quite confusing when I try to do something. You don't know exactly how to approach that using the old API, using the new API. Some example contains the old API, other examples contain the Brain Script. So because of that, it's difficult to start initially. But while we are confronting with different problems, you'll see that CNTK is works pretty well. Now, what is important, what we have found being very important related to deep learning. So probably the most difficult part is how to prepare your training set, how to train your model. Of course, in our case, we try to find as much as image screen as possible. So we use different images from different applications. We also have search on Google to find different images. We also create a small WPF applications for generating different application screens with different controls and of course with different teams. So also organizing your data is very, very, very important. Training your model is very important. So data augmentation gives you an important improving performance. So you know the devil stays in detail. So that's why it's important to take into consideration all these small adjustments which can improve your accuracy. Also, for example, batch normalization, which it's very important to use it when you're training your model. Why? Because it offers you a speed in convergence. Now, another important thing is how to choose the deep learning framework, because as I mentioned before, there are a lot of deep learning frameworks available, and you have to have this in mind that you are doing this for a production environment, so not just for prototyping. And you have to choose very carefully your deep learning framework, in order to best fit in your main application. Another important issue is where you deploy your model. You can deploy it on the server side, or you can deploy it on the client side. Of course, if you are deploying on the server side, you can benefit from unlimited resources. So there you have GPU available. But looking back, for example, in our case, when we are doing the object detection, it's requires to send the image from the client side to the server side. And of course, this will imply a loss in performance. If we are doing the other ways, for example, storing the model on the client side, it requires to take into consideration different client architecture. So it's important to know that CNTK, for example, and TensorFlow doesn't support 32-bit architecture for Windows. Also, it's very important that on the client side, for example, you're not sure if you'll have a GPU available. So you have to take into consideration these facts. Also, it's important, for example, to isolate as much as possible this detection, this deep learning framework from the main application. Why? Because of course, the detection phase requires a lot of CPU or a lot of GPU, and you want to avoid as much as possible different possible crashes or memory leaks. So that's why my recommendation is to use the model in a different process. Now, a thing that it's also important is the size of your model. So in the prototyping phase, you can result with a model which can have 1 gigabyte. But you'll have to keep in mind that in a production environment, to have, for example, the kit having 100 megabytes and your model having 1 gigabyte is not accessible. It's not acceptable. So you have to think about strategy for reducing your model. And one of the strategies to use, for example, quantization, or the other approach will be to look at your architecture and modify a bit your architecture such that it will have a smaller size. Of course, if you are adjusting your architecture, if you are applying a shrinking algorithm, you'll have to keep in mind that you'll probably lose some of your initial accuracy. So this is my conclusions. I hope you enjoy the presentations. If you have any other questions, I'm here with my colleagues. Thank you. Okay.
So guys, questions? I have one. Can you give us an example on how you actually use this?
Yes.
I've seen some screenshots, but I wasn't sure because they were quite blurry.
Oh, can you start my presentation again? Okay, sorry. Okay, so what's the problem here? We are trying to automate an application, and in order to do it, you are making actually a workflow. In that particular workflow, you are saying, okay, for example, you want to open the calculation application, for example. So, and you want to do a multiplication, to multiply by 2. So the first thing which is important is to open the corresponding application. Okay, so it doesn't have any connection with the image processing. Once you have done that, you have to press the 2 and then the multiply button and then the 2 button in order to make the multiplication, then the equal button, So in order to do that, you have to know where the buttons are. So imagine that this is the application and you have a lot of buttons here, 1, 2, 3, and you have to find out where the buttons are. So how you can do that? You are doing this with this deep network. So initially you're applying the OpenCV algorithm, which gives you a series of candidates. Then you are padding those candidates. So those candidates are actually different parts from your image, different areas from your image. Some of those parts can be buttons or other type of controls. Other can be just junk, just simple images. So you have to identify in which position is my button, is my 2 button, in order to move the mouse and click it. So you have these candidates. One of the candidates surely will contain that button. Okay, you apply a deep learning, you apply a convolutional neural network, and as a result, what it will result? Some of the rectangles will be nothing, and other rectangles will be buttons. So you have detected that you have, 10 buttons, 1, 2, 3, 4, 5, and you know right now, after applying an OCR, where is your 2 button? So you know where the 2 button is, and what you have to do right now is moving the mouse over that particular area and send a click message. And actually, what we have done, you press the 2 button, and you are doing this again for the multiplying button. Okay, the multiplication button, and then again for the 2 button, and again for the equal button, and you have done your calculation. But in order to detect where are my controls, you have to use a specific algorithm. You can use it, for example, UI automations, but I have shown there are some limitations, for example, in a Citrix environment for very old application, and you can use a much more wider approach which behaves like we are behaving, actually to rely on the image itself and understanding where the buttons are. Is it clear? Yeah, okay. Thank you.
Thank you. Thank you.
Thank you.